Hello students, we are going to study the next part of organic chemistry, that is alkynes. Alkynes are unsaturated aliphatic, that is open chain hydrocarbons containing carbon-carbon triple bond in their molecule. The general formula of alkynes is CnH2n minus 2. Alkynes have 4 hydrogens less than corresponding alkanes. The first member of alkane series is ethyne. The common name is acetylene. This you have to remember. C2H2. Alkynes are more reactive than alkenes due to the presence of carbon-carbon triple bond. And this triple bond is referred to as acetylenic linkage. The first and the most important member of the series is acetylene, and hence the series is also referred to as acetylene series. Nomenclature of alkynes. Common name is acetylene and it is the first member of the series. IUPAC system. The names of the members are derived from the alkanes by changing the suffix ane to yne. That is, example is ethane, that is ane is changed to yne, that is ethyne. There is no corresponding alkyne to methane, so it starts with ethane only. The structural formula of ethane, that is acetylene, is C2H2, where you can see between two carbons you find a triple bond. And here it is the electron dot structure. Carbon having 4 electrons in its valence shell, each carbon, and each hydrogen with one electron, which forms a bond between carbon and hydrogen. So you have a single covalent bond between carbon and hydrogen, and there are 3 electron pairs which are shared between 2 carbon atoms. So you find a triple bond between 2 carbon atoms. So this is the structural formula of ethyne. Common name is acetylene. Preparation of ethyne, that is acetylene by lab method. So in the lab it is prepared by using calcium carbide and cold water. You can see a conical flask in which calcium carbide is taken and cold water is dropped from the thistle funnel drop by drop, and the reaction takes place. So what happens here is cold water is added dropwise through the thistle funnel into the conical flask containing calcium carbide. Impurities will be present, that is phosphine, hydrogen sulfide and ammonia and arsine. The passage of ethane through the water absorbs all these impurities except phosphine, which can be removed by acidified potassium dicarbonate. All that is not shown in the diagram. The gas ethane formed passes through the delivery tube, which is kept in a beehive shelf under water, and it is collected by the downward displacement of water. So this is the method by which ethyne is prepared in the lab using calcium carbide. This is one of the very important equations which is asked in most of the board papers. So when you check the board papers, you will find this equation will be there in almost all the year. So you find calcium carbide. This is the structural formula of calcium carbide, CaC2. When combines with water, it forms ethyne and calcium hydroxide. The calcium hydroxide remains here and gas passes through the delivery tube, which is collected by the downward displacement of water. This is preparation of calcium carbide, which is not required because we need calcium carbide here for the preparation. So when calcium oxide and carbon are heated to a temperature of 2000 degrees Celsius, calcium carbide is formed. This calcium carbide is used in the preparation of ethyne. Ethane can also be prepared from 1,2-dibromoethane. So 1,2-dibromoethane is boiled with concentrated alcoholic KOH solution. That is, KOH solution is made with alcohol. And when these two are boiled together in a round bottom flask, you get ethyne, which is collected by the downward displacement of water. The general method of preparing ethane is from methane, or it is natural gas, because natural gas mainly contains methane. So when methane is heated or when electric arc is passed up to a temperature of 1500 degrees Celsius, ethane is obtained. This is also called as pyrolysis. Chemical properties of ethyne. catalytic hydrogenation. Hydrogenation means addition of hydrogen. Catalytic hydrogenation means addition of hydrogen in the presence of a catalyst nickel. Can use the other catalysts also here like palladium and platinum. And here nickel is used and heated to a temperature of 300 degrees Celsius. You get from ethyne, you get ethene. That is from a triple bond, it becomes a double bond. The one bond with that is 2 electrons takes up these 2 hydrogen atoms. So you get a double bond between 2 carbon atoms, forms ethene, which on further hydrogenation, this double bond becomes a single bond here. So a bond is a pair of electrons. Those 2 pair of electrons takes up this hydrogen atoms and then you get ethane. So from an alkyne, an alkene and an alkane are formed. So this is catalytic hydrogenation. This is conversion reactions. Very important reactions. They may ask you, how do you get from an alkyne and alkene? So these are the reactions which you have to show. From an ethyne, it forms ethene. From ethene, ethane is formed. That is catalytic hydrogenation. The next is halogenation. That means addition of halogen. The halogen added here is chlorine and bromine. So when bromine or chlorine is passed through ethane in the presence of carbon tetrachloride, you get 1,2-dichloroethane. The triple bond between the 2 carbon atoms changes to a double bond and that pair of electron takes up 2 chlorine atoms. So you get 1, 2. 1 is first carbon, second carbon to which chlorines are attached. So it is called as 1,2-dichloroethane, which on further chlorination or it is called halogenation, this double bond becomes a single bond here and a pair of electron takes up 2 chlorine atoms. So you get 1, 1, that is on both side of carbon atoms you have chlorine and the second carbon also has 2 chlorine atoms. So it is 1, 1, 2, 2, tetra. Tetra means 4 chlorines. Tetrachloroethane. So from an ethyne you get a single bonded compound that is 1,1,2,2 tetrachloroethane. Or in place of chlorine, if you add bromine in the presence of carbon tetrachloride, again the triple bond between the carbon atoms changes to a double bond and takes up this bromine atoms. So you get 1,2-dibromoethene and further bromination, that is halogenation. The double bond becomes a single bond and that pair of electron takes up 2 more bromine atoms. So since there are 2 bromine atoms attached to each carbon and while numbering it is 1 and 2 carbons. So first carbon has 1, 1, second carbon has 2, 2. There are 4 bromines, so tetrabromoethane. So this is how from ethane you get 1,1,2,2 tetrabromoethane. And addition of iodine is reacts with iodine, that is acetylene. Ethyne reacts with acetylene reacts with iodine with difficulty, giving the only product acetylene diiodide. Okay, so you get here only acetylene diiodide. This is not a very important equation, but the reaction with chlorine and bromine are important. The physical properties of ethyne. Nature, gas at ordinary temperature. It is slightly lighter than air. Color and odor, it is a colorless gas with a faint garlic odor. Remember the odor of the gas. Ethane has a faint, means slightly garlic odor. Solubility, very slightly soluble in water, but it is soluble in organic solvent. One of the organic solvent example is acetone. Then uses of ethane, it is used in the production of oxyacetylene torch, that is for welding and cutting of metals, that is shown here, you can see here. So when ethane or acetylene combines with oxygen, it burns and produces a flame which has a temperature of around 3500 degrees Celsius. Therefore it is used for cutting and welding of metals. And ethane gas is also used for artificial ripening and preservation of fruits. It is also used in the manufacture of polymers, synthetic rubbers and fibers. Then test for ethyne. Ethyne burns in air. You can see here. Ethane burns in air with a sooty flame. You can see the carbon particle here. because it is an incomplete combustion. In excess air, it burns with a brilliant white flame. If you get enough of air, it burns with a brilliant white flame, evolving heat. Ethane reacts with dilute alkaline KMnO4 the purple color of KMnO4 is discharged because KMnO4 is purple in color. So when ethane is passed through it, the color gets discharged or it turns green, which serves as a test for unsaturation. This shows that the solution is an unsaturated solution. When ethane reacts with ammoniacal cuprous chloride, it forms a red PPT of copper acetylide. This is the test only for ethane. And ethane reacts with AgNO3, that is silver nitrate, to form a white PPT of silver acetylide, which serves as a test for ethane only. So these two tests will not be answered by ethene, that is alkene or alkane. Now it's a comparative test. You can see here test for saturated and unsaturated hydrocarbon. Alkane is a saturated hydrocarbon and alkene and alkynes are unsaturated hydrocarbons. So test for alkene and alkene. This test is mainly for alkene and alkene. You can see bromine solution in carbon tetrachloride. When alkene is added to this bromine solution carbon tetrachloride, the brown color of bromine remains. The color does not change in alkene. Whereas with alkene and alkyne, the brown color is discharged. It becomes colorless. So this shows that whether it is solution is saturated or unsaturated. If the color remains, it is saturated. If the color gets discharged, it can be alkene or alkyne. We cannot make out whether it's alkene or alkyne, but we can only say it is a saturated or unsaturated solution. With dilute KMnO4, alkanes react with dilute KMnO4, that is alkaline KMnO4 solution. The purple color remains purple. There is no color change. Whereas with alkene or with alkyne, the purple color gets discharged, discolorized, or it decolorized, or it turns green in color. Okay, so here again, you can only differentiate whether it's a saturated or unsaturated hydrocarbon. But these two tests, that is ammoniacal cuprous chloride and ammoniacal silver nitrate, is tests to differentiate between alkene and alkyne. So with alkene, ammoniacal cuprous chloride do not form any precipitate. But with alkyne, a red PPT of copper acetylide is formed. So we can say if no precipitate is formed, it is alkene. If there is a red precipitate, it is alkyne. This is not conducted for alkenes. This test is only for unsaturated hydrocarbons to differentiate between alkene and alkyne. Then ammoniacal silver nitrate. With alkene, no PPT is formed. With alkyne, a white PPT of silver acetylide is formed. So these two tests serves to differentiate between alkene and alkyne, whereas bromine solution and dilute KMnO4 solution is used to differentiate between saturated and unsaturated hydrocarbons. So all these tests are very, very important. So with this we complete the chapter of organic chemistry, because we don't have alcohols and carboxylic acid for this year. So we are completing it with alkynes. So look for the assignments in the description box. Thank you, children.